I'm going to introduce the fifth method today, the proving triangles, the final method. But before we do that, I want to review the four. All right, they got quizzed on yesterday. All right, those four methods. One method. Here we go. 5. Angle, side, angle. Side's got to be in between. Next up, 8.
Sorry. Angle, angle, side.
Yep, if the side's not in between, I want to use angle, angle, side. Let's keep going here. 7, another method. Side, angle, side. Angle better be in between. If it's not, sorry, can't say side, side, angle. And final method, 8. Side, 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 if I know all 3. All right, here we go. Fifth and final method today. And there is a reason why I save it for after the quiz, and I dedicate a whole day on it. Here's the reason why. It is not like the other 4. It doesn't even have the same letters as the other 4. It is a totally different ball game. And that reason is HL. And this is on your paper already here. I'm just going through it. HL. Totally different than the other 4. What's it stand for? The H stands for this word here, hypotenuse, which I'm sure you've seen a few times in your mathematical career. Hypotenuse. And the L stands for leg. HL, hypotenuse, leg. Let me just throw this out to you guys. What do you know about that word, hypotenuse? Anything come to mind when you hear the word hypotenuse? Probably longest side, but it's only the longest side. Anybody know I can only have one type of triangle where a hypotenuse is located? Right triangle, correct. So what am I trying to push you guys towards? This new method, hypotenuse leg, can only be used in right triangles only. All right? You can only use these in right triangles only. All right? Right triangles only. Now, does that mean if I see a right triangle, it's got to be HL? No. Watch. Here you go. Here are 2 right triangles. I'll tell you those angles are equal and those sides. What's the method? What method do I have up here on the board? Why those triangles are congruent? 10? Angle, angle, side. All right, so I just don't want you to get brainwashed right now that just because it can be used in right triangles only, when I see a right triangle, that means HL. No. So what does HL look like? Here we go. Here's what HL looks like between 2 right triangles. What did I just mark there? Those are the what? I know they're sides, but they're also, that's the what of the right triangle. If it's across from the right angle, that's the hypotenuse. Okay? Hypotenuse across from the right angle. So those are congruent. And a pair of legs. That is HL. Is it side angle side? Is this side angle side that I'm showing you up here? Could this be side angle side 2? 6? Why not? Correct. So it's not side angle side, but we do have now H. Take a look. Here's the H. Here's the L. Okay, and HL. So we all good on how this works? Hypotenuse leg before I throw you into the fire with the proof. How many proofs am I giving you today, by the way? Nope, I didn't put the top on. All right. We are going to go for a new record, though, of number of statements. So we're all good with HL. Okay, let's see how it works, because the proof is going to be a lot different, too, when you have to use HL. So go ahead, mark your diagram up. Let's go. Mark your diagram. Write the word given. I need you to start getting in a new habit. All right? Too many of us, and it's fine right now because it's not a big deal, just start writing statement 2, statement 3, 4, and then all of a sudden sometimes we just get stuck and we don't know where we're going. Before you write down statement number 2 for me, make a plan. Figure out why the triangles are congruent first before you just start writing. All right, let's figure out why these triangles are congruent. Is there anything else you're going to mark on this diagram by yourself? And some of you forgot to do this on your quiz yesterday. What else can you mark by yourself that I don't need to mark for you on this diagram? 1.
CB, congruent to CB.
There you go. I can mark CB as a reflexive side. Other than that, that's about it. So let me cover up one of the triangles right now. Would this be the side angle side method? 7, would this be side angle side?
No,
Why not?
because the angle's not in between.
The right angle is not in between these two sides. So side angle side is out. So now let's talk about this new method, HL. Are they right triangles? Yes. What are CA and BD? They're across from the right angles. What do we call those sides now? The ones across from the right angles. 13? Hypotenuse. So I gave you, I don't have to put an S anymore. God, it drives me nuts. Just takes the fire right out of things, kids. Do I have the, no. Okay, start over. Okay, instead of writing an S now, I can write an H for you guys that use the little, I saw a lot of you guys use it on the quiz, which was good to see. So I have the H, and then what's this reflexive side acting as now? That's a what of the right triangle, not the hypotenuse, but that's a leg, all right? Have I written it in? Nope, so let's write it in right now. CB congruent to CB, reflexive. So there's the L. Here's the one piece you got to worry about with an HL proof. Well, actually, let me back up here. So I think you guys might want to write something down here for number 3 here. Usually, what do we need to say about the right angles? I never say that in the proof. Do you? We say the right angles, which I have up there, right? And then usually we say what, Rachel?
That they're congruent.
That they're right. We always say they're right angles, and then that congruent. I got good news for you. We don't need to say they're congruent in an HL proof. Why not? When I write the letters H and L, do either of those two letters represent angles? No. Now, if you do, because I know you're in your robots in your routine, right? You're in this routine of right angles are congruent. Right angles are congruent. If you happen to write that down, I'm never going to take off for it because it's still correct. I just don't need it in an HL proof. So HL proofs only, I don't need to write that the right angles are congruent. But you do need to tell me something, though, that's new for any proof that we've done. HL only works for what type of triangles? Right, so you better tell me you have right triangles. All right, so in an HL proof, you need to tell me the two triangles you're proving congruent are right triangles. So triangle ABC and triangle DCB are right triangles. In an HL proof, you need to tell me they are right triangles before saying they're congruent. Now, what would be my reason? How do you know they're right triangles? That right triangles have right angles. That's the nice reason right there. Right triangles have right angles. So once you tell me they're right triangles, then you can say, all right, now they're congruent by this new method, HL. Hypotenuse, leg. Questions, comments? Now we'll get to a serious one here. You'll break the record of number of steps. All right, take a peek, mark what you got to mark. All right, here we go. Look at your proof statement first, please. Let's look at the proof statement. Let's make a plan before we move on. Proof statement, 1 congruent to 2. We did this on Monday. I'm not going to get angles 1 and 2 congruent unless, or let me put it this way, 1 and 2 won't be congruent unless oh boy, guess I didn't do that great of a job, huh? 1 and 2 are only going to be congruent if the triangles they are in are congruent, right? What's going to be at the what's our last reason going to be why 1 and 2 are going to congruent? CPCTC. But again, that's not true unless the triangles right here that contain angles 1 and 2 are congruent. So we need to get the triangles congruent first so I can say 1 and 2 are congruent by CPCTC. All right, let's see what we got. Let's make a plan before we write stuff down. I got perpendicular lines. They form right angles. Got it. I also have AB and DC. I got a pair of sides. Now let's go to this other given here. And this is why I like this proof a lot. BF, take a look at BF, everybody. Is that a side in one of the triangles I'm trying to prove congruent? No, it's more than a side. So I can't do this. We can't do this and count it as a side. Do you see why I can't count it as a side? It's more than a side. So you can't say it's a side. Congruent, but we're going to use it, though, to get to congruent to DE. I cannot count that as a side. Please don't do that. All right, I cannot count it as a side. Do you see how we can use it, though, to get a side? Don't yell it out. Somebody's going to tell us here in a minute. But do we see how? Yeah? No? Okay. How can I use, let's start there. How can I use this to get to a side in the 2 triangles I need here? What's going to end up happening? 1? Subtraction. Everyone agree I'm going to use subtraction? All right, but not right now, because how many pairs do you need to subtract? 2. I only gave you BF and DE. Where's that other pair that's going to be involved in subtraction that I can write down first? 5? What am I going to subtract from? EF, EF. Yep, reflexive. And now you can subtract the given and EF. Good job, guys. So BF minus EF equals DE minus EF. Subtraction. And what's been our deal all year here? If I do subtraction or addition, substitution to say what I need. And I need BE congruent to FD. So now we have this. Do you see HL? Well, definitely not side angle side because the right angle is not in between, but do you see the H and the L? Where are the hypotenuses? I don't know. I teach this every year. I still don't know the answer to that. 7, where's the hypotenuse? The 2 hypotenuse.
A, B, and DC.
Yep, that was the one I gave you. So here's H, and L, the leg is what we just proved congruent, BE and FD. So there's the H and the L. Ooh, we are still far away from saying it's congruent by HL. What do I still need to tell you? This is an HL proof. I still need to tell you what about my triangles? 5?
AEB and DFC are right angles.
Good. Good. We need to say they're right triangles, but I can't even do that because I don't have right angles yet. Great job. Look at you. So step 5, tell me where the right angles are. Angle AEB and angle DFC are right angles. Perpendicular lines form right angles. Good work, guys. Good work. Now, why didn't I say that on the last proof? Remember, it was given on the last proof. It was given. Again, if you guys are just so in the habit that in this next step you say that the right angles are congruent, that's fine. I don't need it in an HL proof, but I'm never going to mark it wrong because it's correct. What do you still need to tell me though? I'm not ready to say the triangles are congruent because you still have to tell me what about the triangles. 6, they're right triangles. Triangle AEB and triangle DFC are right triangles. Right triangles have right angles. Just a quick comment before we finish it. Remember I was picky about the order you write your letters and stuff? I'm only picky when you write that they're congruent to each other. I don't care that the order is right or wrong when you do this. I only care if the order is right or wrong in this next step when I say triangle AEB congruent to, let's see, if I go AEB, I got to go what? CFD, right? CFD. That's where I care the order matters. HL. Now, the triangles are congruent. Any of the corresponding parts are congruent, including 1 and 2. And what's my reason? After the triangles are congruent, Spencer? CPCTC. Corresponding parts in congruent triangles are congruent. 8 steps, new record. Congratulations. So there you go. There's your 5. Questions? Comments? Concerns? I know I'm really laying it on thick, huh? 2 proofs tonight. So here's the expectation. You get them done. You open up your Chromebook. You check them. You're done for the night. No homework on a Wednesday for me. All right? Do them. Check them. You're done. So should see a bunch of Chromebooks out towards the end of class checking your answers.